Alrighty, so here we are again. Graph valid trees. This is a new question for me. Fresh. So we'll see how this one goes. Yeah, let me just quickly look. So, what to say? Alright, I'll keep my voice a little bit higher this time. I like the gain is down on the mic, the audio. And yeah, the plan basically is solve another problem. So let's get right into it. Let's go. So here we are. Given ed nodes labeled from 0 to n-1 and a list of undirected edges, each edge is a pair of nodes, write a function to check whether these edges make up a valid tree. Given n nodes and a list of undirected edges, each edge is a pair of nodes. How are the edges? It's a vector of, okay, so n nodes labeled 0 to n-1. So each integer is 0 to n-1. So like at edge, I like doing this. At edge, like edges of 0 would be all of the edges to node 0. So if you said like edges of 0, access edges of 0, and then yeah, that's some list of values, 1, 2, 3, whatever it is, 1, 2, 3, 4. Whatever, ... That's what they give you. Tell you how many nodes and then tell you what the edge set looks like. Okay. Write a function to check whether these edges make up a valid tree. Interesting. Huh. And not a binary tree, just any kind of a tree. N equals 5. Let me do something here. I want to actually save my the notes that I make for each problem. Where do I normally save it? Yeah. Okay, that's a fine spot. Okay. I have this bad habit of like basically doxing myself each time doxing myself each time I save something. So here, let's take a look at this. Take a look at this. Oh yeah, okay, we're fine. So the deal is 0, 1, 0, 2, 0, 3, 1, 4. N equals 5, we have 0, 1, 2, 3. That's better. Make like a circle. That way it's a little easier to see the edges. 0 to 1, 0 to 2, 0 to 3, 1 to 4. So this is going to have like, it'll have something like this going on, like 0, 1, 2, 3, 4. Oops. All right. Yeah. So this is what you would get in your edge set. So you have the 0, and actually you would have the other edges too. 2 would go to 0, and 3 would go to 0, and 4 would go to 1. So you have the reverse as well, which is a notable thing. 1, 2, 3 would go. There'd be a 0 here. The 0 would probably come before the 4, or it'd probably be sorted. We'll just leave it as is now. So that's kind of what your edge set would look like. What problem is this that we're working on? Graph valid tree. Leetcode 6261. Something like this. So the thing with trees is there's usually like a root node for a tree. And the main thing with a tree is that there are no cycles in the tree. Excuse me. Like an acyclic graph, basically a graph that doesn't have cycles, is more or less a tree. That's kind of what it comes down to. Now the thing is, the root really, if you think about it, right? Because this tree is obviously this node 5. 1, 2. This is wrong. It's not. It doesn't even exist. So that's six nodes if you're paying attention. Really, any of these could be the root node, because this is not. It's not directed. So like, if you make 0 the root node, that would be 0 to 1, 2, 3, right? 1, 2, 3. And then 1 could go to 4. And then if you make 1 the root node, that would go to 4 and 0, it looks like. Those are the children. And then 0 has 2 and 3. Right, basically, because it's undirected, you can make any of the children can be promoted to a parent, and vice versa. Any parent can be demoted to a child, and for the most part, you should be able to do that as long as you don't have any cycles and it's not directed. 2 is a similar thing, so 2 would be connected to 0, and then 0 is connected to 1 and 3, and then 1 is connected to 4, and 3 would look like. Just thinking of I don't know if like an obvious proof for this. I think it's just 0, and then 0 is 1, 2. 3, 0, 1, 2, and then 1 goes to 4. And then where's the 5th one? 4 goes to 1, then goes to 0, then goes to 2 and 3. So, no duplicate edges, not a multi-graph, undirected, it's the same, not appear together in edges. Oh, okay. Oh, I see. Okay, so they won't have the duplicate edges there. So that's interesting. That's good to know. So you won't see these. This 4 to 1, and this 0 to all these extra edges won't be there. Yeah, that's good. So what makes this one not a tree? 0 to 1, 1 to 2, 2 to 3, the cycle. That's why. 0, 1, 1 to 2, 2 to 3. That's it. That's it. You know, it's really just, yeah. I wonder also if it needs to be connected. if that matters at all. I could find out now, just the test cases. Alright, expected true, true, false. Wait, what? Hold on a second, what is going on? This is true. I made a mistake somewhere here. This one's supposed to be false. Let's do, hold on, let's be true, false, true, right? That's what we're expecting. Expected true, false, true. Okay, now this, we want to make this false now, or see what happens if this is false or not. Yeah, it becomes false. Okay, so in order for, so what they're contending to, basically to be a tree, it needs to be connected. So all the points have to have some edge, and then also what do you call it? You also need so there's this concept of like inbound and outbound edges, basically just edges that are incident on a point. Every point you can check to see there's at least one edge that's incident, then it's connected. That's enough. Actually, no, that's not true, because it could be. You could have everything be incident but still not connected. So actually, what you're going to want to do is probably perform a. I guess a depth first search to make sure you visit every node. Just count the number of nodes you can reach using a depth first search. That should be sufficient. This also doesn't need to be modified. So yeah, so you can do a depth first search to just count the nodes to find out if it's all connected or not. That's sort of one routine that could be executed. Actually, the first routine is better than the depth first search. The first routine would be finding if there's any cycles, which I mean, usually how I do cycle searching is again, I do a search and I just store every node that I visit in a set. Basically mark each node. Yeah. Could even use a bit set for this problem. Something like that. Yeah, I mean that's pretty much it. Yeah. Okay, do both. So, we'll write this sort of like this. Scaffolding here. So we're gonna do a depth first search, and we're gonna just. Do I want to use? I kind of do. I kind of want to use a bit set. Get some practice with that. No, I mean this doesn't work this way, right? Hold on. This doesn't work, I think. Yeah, it's got to be a constant expression. All right, we'll use vector booleans then. It's going to be n, and they're going to be false. And we're going to say, so base case, say if visited of n. So actually, okay. That really basically just stops your iteration at the end of this. If you've already visited the node, just stop there. Don't need to continue. It's really not much. There really isn't a base case. You just loop over the children. So the children set for the edges are going to be so the symmetric edges don't exist, right? Wondering if anybody wanted to throw an extra processing step in here, like yeah. This is kind of tricky. I really gotta think about this. What's tricky about this is that the children and the parents basically you don't, yeah, okay, we do need to have a notion of a parent, the notion of a parent, and differentiate that from the set of nodes that we visited. Because you could very easily say, okay, I went to this node, went to its child, the child says the other node is a child, and then now we've got a cycle. Just to make sure you don't just trace backwards on the parent. That's really the only thing I think that's important. Yeah, that's all. That's really the only thing I think that matters here. Parent visited, and so we do want the children set here. We could build that using the edges. That basically is, well, yeah, because we need to do this properly. So we do actually need to combine this, or yeah, somewhat combine this. we basically want a children. We want an efficient way to get the children set. That's the tricky thing here. And the problem with that is that if we wanted the children of 3, we'd have to, yeah, okay, all right, never mind. So in that case, we're gonna create a map. Or just build children map, or child array, something like that. I'm not really sure exactly. So we'll just say for int I equals 0, I is less than n. We have edges of I. We want to say this is confusing. Let's do it this way. So we'll say A, B, A is V of 0, B is V of 1. What do you want to do? What's up, MGTOW Wolf? Hope your day's going well. Welcome, welcome. Just code things up, man. Just code it up. That's all. Nothing in particular at the moment. Just kind of finagling with some stuff. So I want to do children of A. So I'm going to say children of A, pushback B, and children of B, pushback A. That's, I think, what I want to process these pairs correctly. And the thing is, I'm wondering, will I get... You won't get duplicates doing this because the edges are defined somewhat uniquely. Okay, yeah, so build a child array. Or child matrix. It's more like child matrix. Okay. So now we're going to use a loop over the children. So there's a particular parent and there's a particular target. And we're going to say for each children target, for each int c in the children, we want to DFS, right, and we want to use f, want to recurse, say if c, so if c is not equal to the parent, right, I want to throw that out. We don't want those. So visit event, if we already visited, otherwise we're gonna say we visited this node. Becomes true. And we also have a count too. I have one more thing here, ret, and count equals 0. Increment the count. Alright, so this handles the, we're kind of doing these simultaneously, which is maybe not the best idea, but I think it's okay. This will tell you if we have a cycle. This will basically set that node to visited. This will keep track of how many nodes we visited, and count should be exactly what n is at the end of this. And we're going to loop over every child, excluding the parent, where we just came from. And we call f parent target. So the new parent is going, the target is going to be C, and the new parent is going to be this one. So this, the current target becomes the parent, or the node that we're at, the current node, and then the new target becomes C, the child. And that's pretty much it. You visit every node, counting all the nodes. You keep track of the nodes you visited. Loop through the children set. Use a depth first search. And if you have a cycle, turn false. If not, this is untouched. This ret. And finally, probably want to move these a little closer down. If you visit every node, which the count will keep track of, and you don't have any cycles, then you're in good shape. And it doesn't really matter which parent you start with or what the target is initially. I guess the initial parent could be -1. It doesn't really matter. There's no initial parent, and then target is just any node. It could be 0. It could be if the graph is undirected and it could be a tree, then any node could be the root, I believe, so unless I'm mistaken. So let's try something like this. Let's see what happens here. Let's see how we do. Type ISO bool count. Oh, oops. Forgive me. That was a mistake. Stack Overflow. Nice. No kidding. Uh-oh. Yeah. It's a little tricky. Maybe it's not the best way to check for cycles. It's a little tricky. So let me say this. Let's try this one. Just this one. Let's see what happens. Oh, okay. So that one's fine. What about this one? So it's the cycle. So this doesn't handle cycles correctly, it would seem. That's also fine, right? That counted correctly. But the one with the cycle is the one that's causing issues. So instead of looping infinitely, it's supposed to terminate. So now, actually, I think what you're supposed to do I think this might be why. You just terminate right then and there. That might be it. That might be the problem. Wrong answer. Huh. Always false. No. No. Oh, that's why. It's not n. Oh, of course, that's why. It's not n. It's target. Excuse me. That's the issue. That's why. Confusing n with these other values. Okay, no, we're fine. Our logic is okay. Started doubting myself. It's like, wait a minute. No, we're fine. I think that's it. I think it's that simple. Yeah. Let's try some other test cases. I mean, I don't know. I mean, that's kind of it, right? It's like, how do we... Well, we can do some degenerate test cases, like if we had one node. Nothing here. What happens here? I can try that. Thinking more complicated graphs. It just returns true. About 2 nodes with no edges. Two nodes with a couple of edges. Or 1 edge, right? Okay. 0, 1, or 0, 2, 0, 3, I don't know, 2, 4, 3, 4, 5, 6, 7, 10, or 7, 9, 8, 4, I mean, or 4, 8, rather, or something, you know, just a bunch of junk, 3, 7, 3, 8, 8, 9, who knows, this has got cycles all over the place. Should be false. Okay, now let's prune that down so that way we know it should work. 0 to 1, 2, 3, 2 to 4, let's get rid of 3 to 4, we don't need that. 0, 1, 2, 3, 2 to 4, 4 to 8, 8 to 9, don't need 3 to 8, that'll create a cycle. Something has got to go 5. 5 to 6. How about we can go 4 to 6. Right? So 2 to 4, 4 to 6, 6 to 5. 7 to 9. Something's got to go to 7. We can go like 2 to 7. Oh no, we have 3 to 7 already. I think this is probably enough already, right? 3 to 7, 7 to 9, 4 to 8, 8 to 9. You don't really need 8 to 9 if you have 7 to 9. Right, that'll create a cycle. Alright, true. Alright, let's go for it. Hey, got there. Wasn't super confident. Was a little bit hesitant with that. But I think it's really that simple. It's just you just have to check 2 conditions: that it's connected and that it's there's no cycles. And checking the cycles, you just run a depth first search. You can do both depth first search to check how many nodes are connected, and then also how many check that there's no cycles using a simple vector of booleans, you know, just to keep track of the nodes that you've already visited. Is fine to check if it's if there's cycles. The only issue, right, as I described, there's a couple of caveats here with this problem. Where one, the children set itself, setting that up properly is a little tricky because you also have to keep track of this sort of a parent node or parent node where you don't want to be looking at a child node that's also where you just came from and then checking that as if it's a cycle, right? Because technically every edge represents a cycle, because A to B, you can also go B back to A. So we mean cycles that aren't one edge, right? In order to not consider single edge cycles, we keep track of a parent, the notion of a parent. That's kind of it. I mean, it's like, yeah, the child set you can set up with just a matrix. Just loop through all the edges and set up the child set. You know, kind of get it directly. Yeah, pretty straightforward, pretty easy overall, pretty easy. Hopefully that makes sense. Hopefully that wasn't too bad. I realized I kind of like fumbled and meandered my way through that, so I guess forgive me for that. But that, I mean, that wasn't too bad. You know, that wasn't too bad overall. Could always use more practice, I guess. Yeah, I like that. I thought that was okay. So yeah, thank you for watching. I'm gonna end it there and take a break. Just kind of hang out for a bit. I've been watching these videos lately. I think these are really great. From Soft White Underbelly, this fellow. He's got 1 million subscribers. It's unbelievable. But these are basically just how other people live their lives, I guess. And pretty interesting stuff. It's pretty dark. It's like really dark. A lot of stuff that you never really hear about. Yeah, these are kind of long. I mean, it's interesting to hear about other people's lives. There's this other guy, this guy here I was just looking at. Apparently he's a pimp, and I've always kind of wondered. It's like, what the heck is like, the heck is a pimp anyway? You know, like what is that? Like, how does that even? And like, I don't know anything about them in terms of like, you know, like I know that people who get into sort of bad behavior, usually it's because of really bad upbringings. So you'll often have like a lot of guys that are fatherless. You know, they don't have fathers in their life. They get into a lot of nasty stuff. They're really, their lives are really hard, basically, and they're very prone to being very angry and resentful and bitter and hurting people and things like that. And same thing, the women that grow up fatherless, same deal. They're basically all the negative things in life. They're way more prone to that kind of behavior, self-destructive behavior, damaging behavior, not being able to like handle difficulties in life. You know, if someone else bullies you, for instance, what do, right? A fatherless kid is very likely to become over aggressive to the point where like they might kill the person or beat up the person. Whereas, you know, there's like, it's not always like things that are kind of open-ended where it's not obvious what you're supposed to do. There's a certain tendency for the fatherless kid to really pick the wrong choice. If there's no real obvious answer what the right thing to do is, or something like that. And there's like a lot. I mean, there's like a lot of things. Obviously, as humans are extremely complicated. So there's situations. So for women, it's less obvious. For men, it's kind of clear. It's like they're just one of the big things that they're just way more aggressive than they need to be, and that gets them into a lot of trouble. But for women, they're usually way more sexual, so they lean on their sexuality too much, to the point where they have like a lot of problems. And what's interesting is that's actually what this guy was talking about. It kind of caught my attention. He was saying that what seems to happen, what the two of them were talking about. Yep, most of the times a bad father also means a wrong mother. Females choose wrong. Yeah, I guess so. So like there's this kind of intertwining with women and men, because bad fathers raise bad women who raise bad boys who raise bad women, right? If that makes sense. So you have bad fathers, bad girls, no fathers, more bad boys, something like that, right? Like you have this kind of like intermingling of a lot of bad choices kind of getting compounded. Because if she doesn't have a good father, then she almost doesn't have the ability to pick a good father for her next her children, something like that. At least that's sort of my experience anecdotally. And that just kind of repeats the cycle. So something along those lines. But what's really interesting about this guy was talking about, you know, he says he's a pimp, right? And I was like, what the heck, you know, like to me it always seemed so, I mean, it's so far out of like anything even remotely close to like my life, you know, like it's not like it's something I don't know anything about other than what I just described, like sort of the meta understanding of like, well, in general, guys get into things they shouldn't get into when they don't have strong father figures to kind of guide them through life. that's kind of basically all I know. And actually what was really interesting that he said, and the guy that was interviewing was talking about, he was saying, it seems that to him a lot of the pimps that get into pimping, it was because of some woman who was not good, bad apple, picked this guy out and took him under their wing and showed them how to be a pimp. And then from there he would pimp out other women. That's sort of what they were. I didn't really get too far into it. I only listened to a few minutes, but I thought that was like super interesting because I was like, huh, why would that, like, that seems so strange. It makes a lot of sense because it's like, well, what guy just decides one day to start pimping women? Like, it just seems so outside the bounds of reality. Like, it's just so far beyond anything like realistic. I mean, it's just completely insane. Like, it's just totally like the most deranged, degenerate thing I could think of. Is not only prostituting women, but like being the guy that helps to prostitute women. Like, that's like just so bizarre. And it actually makes some sense now if it's like, oh, well, actually, if women are themselves trying to prostitute themselves, because you really can't do it without her consent, right? Like, if she doesn't want to prostitute herself, you really, I mean, unless you're talking like sex trafficking, where it's total enslavement, totally forced, which that exists, but I don't think most of, I mean, I don't know, I actually don't know, but like, even then, it's like, you know, most people, there is a degree of like choice where like you could commit suicide in that situation, or you can fight to the death to get out in that situation. Like, there's a certain degree of consent involved with these things, which is, I mean, we're getting to really dark stuff, but pimping women is very easy. Remember that there are women that love guys in jail, and even some love serial killers, but that has a reason. Yeah, well, I mean, held it for review. Good old YouTube getting the censorship going. Yeah, there's a lot. I mean, there's a lot to it, I guess. A lot to talk about, but yeah, I think I do think about that from time to time, about like women that like men that do evil things, something like that. Being attracted to darkness, something like that. Hi, how's it going, Fedo? Welcome back. Hello. Welcome. It's kind of an interesting thing. It's a little weird. It's a little strange because, like, ultimately it's darkness, right? Like, ultimately it's evil. It's wrong. Like, it's not good. Like, even if women are attracted to it, it's still wrong. Like, for guys, that's a temptation to be evil, knowing that women will reward, like, knowing that there's some kind of earthly reward, right? By the way, which is why you want to follow Jesus, right? It's very clear what you should and shouldn't do. If you follow what Christ says, follow God and not women, right? There's this expression: success has no woman attached, but regret has many. I thought that was an interesting expression. I don't know if it's true, by the way. I mean, I think it's a little bit, that in itself is a little too pessimistic, because I thought about that some more. I was like, you know, actually, I would consider raising a family a success, right? Like, if you raise a family successfully, like, that's kind of one of the main things you're supposed to do as a man, and you need a woman for that. So it's not really a true expression, but it gets the point across, right? That, like, a lot of guys have this temptation to follow women instead of following what's right, and a lot of these women are not, you know, they're basically to lead them to death, quite frankly. But I did find that very interesting. So when I take my break here, I'm gonna go watch more of this, learn more about this guy. But he was saying, yeah, the interviewer had agreed. He's like, it seems like a lot of the guys that get into pimping, it's a woman that gets them into it. It's like, huh. That would make sense, I guess. Basically, the prostitute wants to use a pimp because they want to use these guys, because they're already using guys. They're using their sexuality to get what they want. Same, you know, as I was saying, like, you know, men, when they're kind of broken, they tend to use their aggression women, when they're kind of broken, they tend to use their sexuality. And I guess, yeah, if you're prostituting yourself out, there's like certain things you want. Cowboys start their life at 30s, and bad boys always win until they're 30. Then they start the decline. Yeah. God boys and bad boys. Is that what we call them now? You know, that's, I mean, not to deride women too much here, but, or at all, but just the truth is, when she's really young and fertile, she has a lot of ability, a lot of sway over men. And that's basically what prostituting is trading that power for just money. I mean, just plain old material goods, instead of using it for what it's supposed to be used for, which is having children. Locking down a guy that's, you know, just one guy who's going to take care of her and her family. She's basically just spreading herself around to a whole bunch of men, abusing what she's been given, what God gave her. And so that would make sense that's how pimps get into it, just because they can't make any money without the woman paying him. He can't make any money without her paying him, because life is what's valuable. So she's being sort of the gatekeeper for life. She kind of hasn't had this natural ability to just kind of extract resources from men. And men, obviously, you know, they're kind of geared to generate resources because that's what men do. It's a good tweet that addresses this topic, sort of. Yeah. Yeah, it's pretty wild stuff. It's pretty crazy. I'm actually gonna I guess abruptly change the subject. Yeah, it's just what I've been paying attention to recently. But it's really interesting stuff, I have to say. I'll probably talk about it later some more at some point. But I want to end this video because this is technically supposed to be just a video about solving that problem that I was solving before. So let me say thank you all for watching. Come by and say hello. Appreciate it. I'm gonna end the live stream here just so the video is sort of, you know, somewhat condensed. It's not that condensed, but a little bit. And then I'm gonna take a break. Probably watch more of one of these videos because I'm curious about it. Hang out for a bit, and then stream again, but another problem. But yeah, if you could find that tweet though, by the way, Fedo, I would be interested. not to see ya. Okay, yeah. All right. So talk to you soon. Thanks for coming by and saying hello. I do appreciate it.